When we graph a quadratic function, the graph is going to look like this. It's like a U. It's called a parabola. There's some parts of this I want you to know the names of. One of them is the vertex. That is going to be the point that is either the lowest point, like in this parabola that's opening up. This is the lowest point. If it was upside down, it would be the highest point. If we draw a line right down the middle that goes through the vertex, you're splitting the parabola exactly in half, which makes this real easy for graphing points. If you know what one point is, its evil twin is over here on the other side. 3 units over, this would be 3 units back. Same thing with this point. It's going to reflect across that line. So we call this an axis of symmetry. And it has an equation. This is the equation x equals 0. That's what equations for vertical lines look like. It's kind of confusing because they look like points too. It's easy to get though because it's always going to be the x coordinate of your vertex. If I take this parabola and shift it over, its vertex moves. We're now at 5, 0. And its axis of symmetry goes through that. And the equation changes. So instead of being x equals 0, the axis of symmetry is now x equals 5. On Desmos right now, I'm going to explore what happens with parabolas when we do things to them, at least to their formulas. All right, here's the parent function x squared. That's what it looks like. What happens when we put x plus 5 inside the parentheses and square it? Oh, weird. It stayed the same shape, but it slid backwards 5. Why did it go backwards? This was x plus 5. Well, let's look at that point. In order for that to be equal to 0, you have to put a negative 5 in there for x. You've got to zero out what's inside the parentheses. So that's why that backed up to the negative 5. So what do you think is going to happen when we do x minus 5 squared? It went forward. And again, y equals 0. In order for that to be true, then the x had to be a positive 5. Well, what happens then if we have the number on the outside, not in the parentheses with the x, but just on the outside? X squared plus 5, here's our parent function. Ooh, that went up 5 units. Didn't change the shape, it just went up 5. So x squared minus 5, what do you think is going to happen with that? Yeah, went down 5. Oh, that's pretty cool. So to slide your parabola up and down, it's that constant that's on the outside. And I'm going to tie this all together in a minute when I show you the vertex form of the equation. And if you want to go side to side, you have the number on the inside. What happens if you just multiply x squared by something? How does that change the parent function? Oh. It made it skinnier. You multiply by 2, you get skinnier. Okay. What happens if you multiply by something bigger? Let's multiply by 5. Oh, it got a lot skinnier. Let's multiply by 15. It's getting skinnier and skinnier. The bigger the number, the skinnier your parabola. It looks like it just means it's going up faster. Well, what about some number that's between 0 and 1? I don't want to go negative because negative will do something else. Let's do, how about 1/2? What does that do? Oh, it made it wider. Okay. 1/5, much wider. 1/10. You pick a number that's between 0 and 1, and your parabola is getting wider, fatter. In other words, it's going up, but it's not going up as fast as that parent function. What happens if I make it negative? Ooh, it flipped it over. Look at that. It made it a mirror. Okay, that's cool. All the same rules are going to apply. A larger number, even if it's negative, is going to make your parabola skinnier. If we add numbers, it's going to slide them up. Okay, what did this thing do? It's negative, so it's going down. It's got a 5 in the front, so it's skinnier. I added 5 on the inside, so it backed up to the negative 5. And I added 5 on the outside, so then it went up 5. Oh, that's super fun. It all ties together in something beautiful called the vertex form of an equation. This is what it looks like. The h and the k are going to be the vertex. If you understand how this works without even graphing, you can look at the equation and go, oh, I see the vertex. And the a, the number that's in front being multiplied, is going to make this thing narrower or wider. If it's negative, it's going to flip it upside down. Let's practice just reading the equation. Find the vertex and the axis of symmetry. Well, here's our vertex form of the equation. The trickiest part of this is the thing that's happening on the inside of the parentheses. Remember when we put something on the inside with the x, the graph moved opposite of what we thought it was going to. When we put a +5, it went backwards 5. That's because there's a minus in here. So this negative sign is telling you to do the opposite. So, and when you see the h, you are minusing a +2. So the x-coordinate of our vertex is +2. Now the k, being a -1 down here, but in the formula it says it's plus k, the k is the thing that moved it up and down. So when we said +5, it went up 5 like we expected. If you have a -1 here, it means they are actually adding a -1. So your y-coordinate of your vertex is going to be -1. Your axis of symmetry is always going to be the line x equals whatever the x-coordinate of your vertex is. If you get it, pause and do number 2. Otherwise, I'm moving on right now. All right, we have another -3. Remember, it's opposite land. So that means our vertex x-coordinate is +3. +4 on the outside means this thing's going to go up 4. And so the y-coordinate moves up to the +4. The axis of symmetry is going to be x equals 3. The trickiest part is what's happening on the inside of the parentheses. Since this says it's a +2, that means in order to get that plus, they must have subtracted a -2. Just think opposite. This is the math, but if you just think I have to change the sign to be the opposite of what I'm looking at, that's what most people do. So your x-coordinate of your vertex is -2, and your y-coordinate of your vertex is +3, hk. The axis of symmetry is going to be the equation that goes through that -2, which is going to be x equals -2, the line that goes through that. Try number 4, and I'm going to do it. So this is a +4, so your vertex x-coordinate has to be -4. Just think opposite. And the outside, the k, stays the same. It does exactly what it's supposed to be doing. This is the reason why I wanted you to see the visual of what happens with the parabola when you do these things on a graph. When we put the +4 on the inside, we expected it to go forward, and it went backwards. Opposite land when you're inside the parentheses. Your axis of symmetry is x equals -4. Now we have to learn how to graph a parabola if given the equation in vertex form. Let's start with the parent function here, x squared. From the vertex, we have other points we have to be able to find. So the way this one works, there's a pattern to it. If you go over 1, you will go up 1, and there'll be a point there. If you go back to the vertex and go over to the 2, to get back up to the parabola, you go all the way up to the 4. You're looking for a pattern here. Now, in a different equation, x plus 6 squared minus 2, this same pattern works. Over 1, up 1, over 2, up 4. Different equation, but I still see the same pattern. And over here, x plus 5 squared minus 1, the same pattern works. Over 1, up 1, over 2, up 4. Well, so what's going on here? This a for all of these is 1. This is the normal way a parabola moves from the parent function x squared. Even if these functions are different, the shape is still the same. So what's going on here? If you move over from the vertex 1, we ended up going up 1. If we went over 2 units, we ended up going up 4. My graph is too small here, but if I go 3, I think I'd be going up 9. You see the pattern? 1 is the same thing as 1 squared. 2 is going up 4, which is 2 squared, and 9 is 3 squared. I call this the parabola pattern. It's just how these parabolas move. You go over 1 unit, you square that unit and go up that many boxes, and it doesn't matter where the vertex is or where you start. Now, that has to do with all of these, where the a is 1. What happens if this a changes? Does this pattern change, or can I keep using it? Let's check it out. Here is 2x squared. This is the regular pattern, but what is this guy doing? How does that 2 affect it? So we're going to go over 1, and up until we hit the parabola, and there's our point right there. So we ended up going over 1 and up 2. Well, 2 is the same thing as 2 times 1 squared. Go back to the vertex and go over 2 units. I have to go all the way up to the 8 before I find a point on the parabola. So when I went over 2, I ended up going up 8. Well, how does that work with this? That's 2 times 2 squared. So I'm still following that same parabola pattern. 1 squared, 2 squared, 2 times 4 is 8. And if we were going to go up 3, which we're not because I'd be going way off your screen, it would be 2 times 3 squared, and we'd have to go up 18. Let's try it with 3x squared. What is that 3 going to do to my parabola pattern? I'm going to go over and up. I go over 1. I have to go up 3 units. 3 is the same thing as 3 times 1 squared. Let's see if this still works. 2, I have to go all the way up to the 12. So if I go over 2, 3 times 2 squared, that's 3 times 4, that is 12. It works. So that's how we're going to move when we're given a blank graph and an equation. Here we go. I'm going to need this guy right here to figure out what the vertex is. I have the HK. So for this equation, y equals x minus 1 squared plus 2. This is in vertex form, so the h is 1 and the k is 2. So I find my vertex, I go over 1, up 2. There's your starting point. Where do you go from here? The a equals positive 1. That means it's a normal parabola, and we're going to follow that normal pattern. I'm going to go over 1, up 1. Over 1, up 1. And then you go back to the vertex. This is really important. You're not jumping off the point you just drew. You go back to your vertex. Go over 2 points. Then you're going to go up 2 squared, which is 4. 1, 2, 3, 4. And you put a point right there. Now, you have 3 points, and you can draw half of your parabola, but to get the points on the other side, you need to do some reflection. There is an axis of symmetry. You can draw it in, or you can imagine it there. It goes through your vertex. This first point is 1 unit away from that, so the evil twin point would be right over there. 1 unit on the other side. This point is 2 units from there, so we're going to back up 2 units and put a point there. Now, I cheated and I used the computer program to draw the parabola. I am the worst at drawing these. Please be patient with yourself. I have literally been drawing parabolas for 50 years and I still suck at it. I would give you credit even if it looks bad. Make sure your points are all in the right spot and your teacher will be kind. All right, let's try this one. Y equals 2 times the quantity x plus 4 squared minus 3. Let's find the vertex first. That just has to do with the h and the k. So since this is a plus on the inside, remember it's opposite land on the inside, so we have to turn that to a -4. The outside stays the same, so my vertex is -4, -3. -4, -3. My A in the front is +2. Positive means it's still opening up like normal, but it's going to be a little wider. So if I go over 1, I'm going to end up going up 2 times 1, which is 2. So over 1, up 2, and you put a point. And then I go back to the vertex and then move over to the right 2 spaces, and then I will move up 2 times 4. That's going to be 8. So go back here and then go up 8. And on paper, that's pretty much all you're ever going to do because these things go off the page pretty quickly. Now that gives us 3 points. We need to get the other 3 points. So I'm going to want to reflect and bring in that axis of symmetry. We're going to reflect this point over to the other side. And we're going to reflect this point over to the other side. We now have 5 points, and we can draw a pretty decent parabola, unless you're me. Computer, yay! If you want to try it on your own, go ahead and do a pause. Otherwise, I'm going ahead with this one. There's a little bit of a difference in here. Finding the vertex is the same. 3, +1. We go here. We got the vertex. The difference here is this is negative. A being -2 means it's going to be a little bit wider, but it's going to open down. So go over 1, I'm going to go down 2. So I'm going to go over 1, down 2. Then I'm going to go back to the vertex. I'm going to go over 2, and then I'm going to go down 8. There it is. To find the other points, we reflect. This guy reflects across to this side, and he reflects across over here. And then you do your best to draw a parabola. And almost everybody's going to be better at it than me. And there it is. This is the beauty of the vertex form. It makes it a lot easier to graph. Thank you guys for watching. If this was helpful, put a like on it, please. I will see you in the next one. Bye.